As we start to look at the rate of change questions, we need to identify just that the rate of improvement refers to the change in the function with respect to its variable, in this case t. So I've pulled a question similar to example 13 from your textbook, where we want to be able to identify the rate of improvement at a particular age. So to do so, we need to find the derivative function. Using our notation, we're finding the derivative of age with respect to time, dA on dt. So the function which was 1/3 root t becomes 1/3 times by 1/2 t to the negative 1/2, which we can simplify to become 1/6 root t. When substituting a given value, this time t is equal to 9 years old, we can find the rate at which this person's spatial concepts are changing at 9 years old. So at t equals 9, we would have dA on dt being equal to 1/6 root 9, which is 3, so we get 1/18. The result of that being in years, the original units of years, meaning here we're just looking at units per year. For a similar concept, but for t equals 16, we substitute 16 into our function. The rate of change is going to then be 1/6 root 16, which is 4, 1/24 units per year. For part B, we're trying to identify that this must be positive for the given domain that we were looking for. Now we've already found the derivative above, so if we restate that, what we're doing is we're looking at each component. The only variable that we have in that result is the square root t on the bottom. So if we look at the numerator, 1 is always greater than 0. If we had a function on the top, that could be a little bit more complex, but the numerator is very easy in this case. The denominator, again we have 6 root t. Because the square root value must always be positive, especially for our given domain, our result here must always be greater than 0 as well. So when you put those two components that make up our rate of change together, we end up with a positive result.